We're solving problem 13 from the AMC 12B from 2023. A rectangular box P has distinct edges A, B, and C. The sum of the lengths of all 12 edges P is 13. The sum of the areas of all 6 faces of P is 11 halves, and the volume of P is 1/2. What is the length of the longest interior diagonal connecting two vertices of P? So we have this rectangular box, not drawn to scale, but say we have this 3-dimensional box, and it tells us they have the vertices of lengths A, B, or edge lengths A, B, and C. So A, B, and C, it doesn't really matter which one's which because we don't know their values, and we can swap the variables around, so it doesn't matter. Now we can set up equations for this. The sum of all 12 edges of P is 13. Let's start with that. The edges are these lines, and there's going to be these lines in the background. So this is basically, well, let's start with the A's. There's 1, 2, 3, 4. So this is 4A plus 4B plus 4C. And we set this equal to 13. So we have that. The sum of the areas of all 6 faces of P is 11 halves. So if we find this area of this face AB, that's obviously area AB. And since there's 2 of those, it's 2AB. And we can apply the same logic to the other multiples of the areas. So this is 2AB plus 2BC plus 2AC. This is equal to 11 halves. And the volume of P is 1/2. That's simple. A times B times C is 1/2. Now we want to find the area, or rather the length of this point from this point. So it's like this. So it's basically the diagonal of the diagonal. So, and this question gives you all the materials to use an A plus B plus C times A plus B plus C. And now, well, if we have, let's take a look at this first one. What you can do is, well, divide both sides by 4 to get A plus B plus C is 13/4. We now have all the tools for us to solve right now for this length right here, basically. Why? Well, if we do A plus B plus C times A plus B plus C, we basically give us the area that we want, which is, well, that's a good question. What is the area that we want? Well, we have this diagonal here, and if we use the Pythagorean theorem a lot, well, that diagonal, or what we want to find, is going to be the square root of A squared plus B squared plus C squared. Okay. And we have all the tools at our disposal. A plus B plus C times A plus B plus C is equal to A squared plus B squared plus C squared plus all of this 2AB, 2BC, 2AC, which is in turn 11 half. I'll rewrite it over here. So A plus B plus C times A plus B plus C is equal to C squared. This is equal to, and then you add the 11 halves, and then you have to add the A, B, C, which is 1/2. Now we have set up an equation for what A plus B plus C times A plus B plus C is, right? Well, we also know that, well, This is simply the addition of these two, and then you square it. So this is going to be equal to 169 over 16. Well, why? Well, that's because we did a plus b plus c, multiply them together. And we already know that one of these is 13/4. So when you multiply these two together, it's the square. Now, when you subtract all these 11, this 12 halves, this 6 from here, we can get a plus b plus c. So a squared plus b squared plus c squared, 81 over 16. So we want to find the square root of a plus b plus c squared. So the square root of 81 over 16 is 9/4, our desired answer.